Hello everyone. Today we will discuss about covariance matrix. Before starting the topic, let us quickly go through the formula to calculate the variance and covariance. Suppose if we have two variables x and y, each with n observations, then the variance and covariance is calculated by xi minus x bar the whole square summation from I is equal to 1 till n divided by n minus 1. What is x bar here? X bar is nothing but the average of the observations of x variable, that is x1 plus x2 till xn the whole divided by n. Now there are separate videos discussing the meaning and significance of each of variance and covariance. In this video we'll only focus on covariance matrix. Now consider the data set with n observations and p features. Studying the covariance matrix of this data set is crucial because first, when you are dealing with multivariate data such as this, covariance matrix provides a compact summary. And second, many statistical algorithms such as principal component analysis, they rely on covariance matrix. So the formula to calculate the covariance matrix denoted by this sigma is 1 upon n minus 1 x minus x bar the whole transpose multiplied by x minus x bar. Let us try to solve for first n is equal to 3 and p is equal to 2. As you can see, the first step in calculating the covariance matrix is subtracting the mean values from each value or from each column of the data set. This process is called centering the matrix. As you can see, here we have the x data set and we are trying to find x bar. So x bar is calculated by adding all the values and then dividing by 3. Now if you see, the mean vector in this case is a row vector of dimension 1 by 2. If you want to subtract this vector from each row of the matrix, this is the matrix. If you want to subtract this vector from each row of the matrix, you can easily do it in Python with the help of NumPy broadcasting. The term broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations. Therefore, here the 1 by 2 vector will be broadcasted into 3 by 2. X minus x bar denotes the centered matrix. As you can see, the calculations for x minus x bar. Once you have the centered matrix, you can multiply the transpose of the centered matrix with itself and finally divide it with n minus 1 to get the covariance matrix. At this point, you can pause the video to understand the calculations. At the end, if you look at the expression in the top left, this expression, you can see that this is nothing but variance. Similarly, if you look at the bottom right expression, then this is the variance for the second variable, whereas this is the variance for the first variable. The off diagonal elements represent the covariance between the first and the second variable. This is the covariance matrix. Now keep in mind the dimensions of the matrix. Here the original matrix X was of the shape n by p. Therefore the formula to calculate the covariance matrix was x minus x bar the whole transpose multiplied by x minus x bar. If x was of shape p by n, then the formula would have been x minus x bar the whole transpose. Most of the times you will see the definition of covariance of x as xx transpose or x transpose x. This just means that the x they are talking about here is already centered. As I told you that the first step in calculating the covariance matrix is centering the matrix. As you can see from here, the first step in calculating the covariance matrix is centering the matrix. There is one more way that you can use to center the matrix, and this is the way. Calculating H is equal to In minus N inverse E multiplied by E transpose. So you have to either pre-multiply or post-multiply X matrix with this H. Here H is of the dimension n cross n, and E is a vector of ones, that is E is equal to 1 1 1, and the dimension of this E will be also n cross 1. Let us again consider the case of n is equal to 3 and p is equal to 2. Here you can see the whole calculation of whole process of calculating H. Till this point, this is H. Now the dimension of H is 3 by 3, and this is X, and the dimension of X is 3 by 2. So here in this case we will multiply X with H just to make sure that the dimensions are consistent. Therefore Hx will be of dimension 3 by 2. After calculating the H, we multiply X with H to keep the dimensions consistent, and thus we get the centered data. Hx is nothing but the centered data. Once you have the centered data, the remaining process to calculate the covariance matrix is the same. Now once you have the covariance matrix, what is the importance of covariance matrix, or let us study some properties of the covariance matrix. It is a square matrix, so that means the calculation of determinants, eigenvalues, powers and inverses is much simpler and faster than other types of matrix. It is a symmetric matrix, that means covariance of X is equal to covariance of X the whole transpose. That also means that the upper triangular elements are the same as lower triangular elements. The third property is diagonal elements represents the variance of each variable. So the first element in the diagonal represents the variance of the first variable. Similarly, the second element of the diagonal represents the variance of the second variable. Off diagonal element represents covariance between two variables. And the next property is non-negative definite, that is variances cannot be negative. You will have a separate video on each of these topics soon. Hope you enjoyed the video. If you did, then please like, share and subscribe this video. Thank you.